magnet covered with Teflon so it doesn't react with the chemical. That will spin for me. And I can put that in my flask. And it'll do my spinning for me. So then I can add this chemical. And if you see a change, tell me, all right? See any change yet?
Yeah.
What's the change?
There's like a
Doubled the volume, didn't we?
More liquid.
We'll add some more. Okay?
There's
a color change.
Oh!
This is an oscillating reaction also. Now keep watching because the blue's going to go away now.
Gina, is it blue?
We'll go back to the yellow. And it'll pop to blue again.
You sure?
Now you can see that the different reactions last for different amounts of time. The blue reaction is much longer than the yellow, and the clear is much shorter than both of them. I call this my sled reaction, because in the wintertime, you drag your sled up the hill, that's the blue reaction. You sit on it, that's no color. The yellow is you ride down the hill, and then a long drag back up the hill again. So this will keep going back and forth, because there's actually 3 reactions in here. 2 of them are starch and iodine. Starch and iodine, when they get together, they form a blue color. There's also some acid in there, and the acid will rip apart that. You get the colorless, some more iodine forms, sees the starch, blue again. So that'll keep going back and forth as an oscillating reaction. I had to get a sample the other day, and Max and Bill know it's very important to label your chemicals, so I've got some K9P.
Is that true?
Grabbed a quick sample this morning out on the road.
See that? See that?
Oh, it's delicious. Can't do that with orange juice, though.
There's dry ice on the bottom.
All right, what I had in there, I had a powder that's found in everyday items. Diapers, exactly. In the liner of the diaper is this powder called Waterlock. And the Waterlock will hold up to 800 times its own weight in liquid. That's why when you see a baby coming out of a swimming pool, the diaper is holding half the water in that pool. The thing's like giant. It can hardly walk. These were first invented by NASA for use up in space. The astronauts wear them when they're out on a spacewalk, because when they go up there, they go out on a spacewalk, they have to go to the bathroom. There's no porta-john around, is there? They go duck into? No. So they go in their diaper, then they come back into the space station. They add some table salt. This is just regular table salt. And that causes the Waterlock to let go of the water, turn it back to a liquid again. The astronauts can then filter it and get the Waterlock back, make some more diapers, and then use the water, distill the water to use within the space station. Because there's no hose going up there either. So whatever they bring with them, that's the water they have for their trip. They also use this in plants. When gardeners mix up the soil, they put some of the Waterlock beads, the little white beads, in with the soil. It grabs the water when you water the plants. Normally, you water a plant, the water goes right down through. This way, the Waterlock grabs it, and then the salts in the soil cause the water to come back out of the Waterlock slowly. So you get a much better watering for less water. Emily would be happy about that. The one you asked for. I had a party at my house the other day, and after we sat around talking for a while, everybody was thirsty. So I went to the fridge, and all I had was a pitcher of apple juice. So I gave the first person some apple juice. The second person, however, said they didn't like apple juice. So I said, it's okay, I'm a chemist, so I'll make you some grape juice. So I made them some grape juice.
Whoa.
And that's the response I got then too. So I said, with that response, I'm gonna make a whole pitcher full of grape juice.
What?
Exactly. So then the next person didn't like grape juice. So I said, again, not a problem. We'll just make you some apple juice. Gave the next person some grape juice. And gave the last person some apple juice.
Oh my.
And after we had got our drinks, everybody was happy. I said, why don't we just start again and give me a pitcher of apple juice that I can put away in my refrigerator.
I think there's Can I come sometimes?
You don't want my apple juice. Okay, for this one we need to count to 5.
1, 2,
3.
Oh, we gotta count something. Let's count water, because we're all about ecology today. So let's count 1 water, 2 water, 3 waters, 4 waters, 5 waters. We're gonna do that over and over. When we get to 1 again, I'm gonna pour this into the front one, and we'll do that every 5. All right? 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. 1 water, 2 water, 3 water, 4 water, 5 water. I didn't test this one, I hope it works.
Water, 4 water, 5 water.
There we go, 2 water.
2 water.
3 water.
4 water. 5 water.
1 water.
2 water.
3 water.
4 water. 5
water.
1 water. 2 water. 3 water. 4 water. 5 water. 1 water. 2 water. 3 water. 4 water. 5 water.
Did it?
5.
6
Ah!
All right. These solutions are somewhat old and they're temperature sensitive too, but this shows if you do the same thing the same way, you should get the same reaction. And that's very important for us here at Perkin Elmer, because if I took chemical A and mixed it with chemical B, and I had no idea what it was going to make, we couldn't make any money here, could we? Because we need to know what we're going to make when we put a reaction together. So this one, we mixed them at the same interval, and they flipped about the same amount of time. I did have Haishan fill 5 of the beakers, so I'm gonna pin it on him. What are we having for lunch today?
Pizza.
Pizza. Got my pizza board here with a little salt on it. Got a little jar of oil. Everybody likes some oil on their pizza, right?
You always have oil on your pizza.
Well, let's see what happens to this oil then.
Oh.
It crystallized inside. This is actually a supersaturated solution of sodium
Sodium.
acetate. Sodium acetate, which is the liquid that they use to make salt and vinegar potato chips. The acetate is the vinegar, and the sodium is the salt. When this works correctly, you get a nice tower of salt. I heated this, it was mostly solid with a little bit of liquid. Then you heat it, and that heat forces the liquid, the solid, to turn into a liquid. When I poured it and it touches the crystals that are already here, it turns from the liquid into a solid. This is a little bit warm right now. Come feel this for me, please. Is it nice and warm? So the heat that I put into it to make it go from solid to liquid comes back out when it goes from the liquid back to the solid again. I get that heat back all the way through the pellet. This one, same as when I wrote on it, the water didn't bring it through the paper or anything. All right, that's my show. Hope you enjoyed it.
Yay!